Tonight's lecture is over microplastics. When Sherry Mason pulled up the net after plunging it into Lake Superior, she couldn't believe her eyes. It was July of 2012, and Mason, a chemist, was aboard the U.S. Niagara, which is a 198-foot-long teaching sailboat conducting the world's first survey of plastic pollution in Lake Superior. Mason recalls, "I'm looking down at the net, and I see this one little ball of styrofoam, just sitting there in the middle of all this algae." It was unreal. She'd found plastic in her very first sample. On that trip, Mason and her students found several other big plastic pieces, including a wrapper from a cigarette box and parts of a bottle cap. But they didn't see the rest until they got back into the lab. When they used a microscope to count the particles that were too small to see, they found that Lake Superior's water harbored some 30,000 plastic particles per square kilometer. In subsequent sampling trips, they found even more. Lake Ontario had 230,000 plastic particles per square kilometer, which meant that its waters harbored concentrations of plastic particles higher than reported for any other body of water on the planet. These plastic particles, known as microplastics, that float through the Great Lakes are tiny. Most are less than 1 millimeter in diameter. By definition, they are plastic less than 5 millimeters long, but that doesn't mean they're harmless. To the contrary, many are embedded with hazardous chemicals, dyes, plasticizers, and flame retardants, among other things, that likely leak out from the plastic into the surrounding water. Microplastics can also absorb toxic substances from water. The plastic becomes like little poison pills, says Mason, who is currently working as a professor at Pennsylvania State University, Behrend. These microplastic particles are so tiny that they can be easily ingested by organisms at the very base of the food chain, like plankton, and they can be carried by these organisms up the food chain and ultimately into us, carrying those chemicals along the way. Studies have also shown microplastics showing up in stool samples of human subjects. As Mason and other scientists have shown, microplastics are virtually everywhere in waterways, ocean, soil, and even the air. Mason discovered microbeads from personal care products, facial scrubs, and toothpaste, as well as tiny fibers from polyester clothing. Microplastics are turning up everywhere, in ocean water and sediments, in Arctic snow, and in the bellies of fish living deep below the surface of the Gulf of Mexico waters. A 2019 study of the air in the pristine French Pyrenees Mountains found 249 microplastic fragments floating around per square meter. Considering that the world produces more than 400 million metric tons of plastic each year, and since plastic's inception, more than 8.3 billion metric tons of plastic has been produced, is it any wonder that tiny plastic fragments are now scattered around the planet, covering nearly every surface? Scientists have many questions about how these microplastics are affecting the environment, marine and land organisms, not to mention human health, and they're starting to get answers. And that brings us to key concept number 1. Solid waste can be said to be unique to human societies because in nature there is no quote-unquote waste. The discarded matter of one organism becomes a resource for another. So solid waste, all manner of materials that we discard, including trash, sewage sludge, and agricultural waste, to name a few categories, is uniquely a human concept. In natural ecosystems, there is no such thing as waste. In a circular pathway, matter expelled by one organism is taken up by another organism and used again. Forms of matter that are dangerous to living things, like arsenic and mercury, tend to stay buried deep in the underground and are released only during extreme events like volcanic eruptions. Human ecosystems are another story. We tend to handle matter in a linear manner. Matter is extracted, transformed, used, and then discarded, often in ways that make it hard for us to reuse or for nature to reclaim. We do this by converting usable matter into synthetic chemicals that can't easily be broken down, and by buying readily degradable things in places and under conditions where natural decomposition processes can't run their course. However, when we throw trash away, it isn't gone for good. It's still somewhere in some form. This is consistent with the law of conservation of matter, which tells us that matter can't be created or destroyed, it can only change forms. Well, that sounds like the first law of thermodynamics. Whatever we dig up or create stays with us. Whatever we throw away stays with us too. Plastic trash may break down into smaller and smaller pieces, but it doesn't cease to exist. One solution to keeping plastics out of the environment is to change our focus away from waste disposal to waste management, preventing its generation in the first place. To do that, we must go back to the beginning, before the things we throw away are even made. By conducting a life cycle analysis to assess the environmental impact of every stage of a product's life, from production to use to disposal, companies are looking for ways to reduce the amount of waste generated by their products. More and more manufacturers are tackling the problem earlier still, considering reuse potential in the design stage, making it easier to turn waste back into resource. So not all waste is created equal. Waste that can be broken down by chemical and physical processes is considered degradable, even if that degradation takes a long time. Waste that can be broken down by living organisms, such as microbes, is considered biodegradable. Some waste, mostly synthetic molecules like the pesticide DDT and chlorofluorocarbons, or CFCs, once found in aerosols, is considered non-degradable. These molecules are chemically stable and don't readily break down. Different types of plastics have different degradation rates, but for all, it is generally quite slow. After all, one of the perks of plastics is their durability. Exposure to sunlight in an oxygen-rich environment causes plastics to chemically change and become brittle, breaking them into smaller pieces. This breakdown can occur more quickly with the additional weathering action of wind and waves, which produces the tiny plastic bits found in water bodies everywhere. But breaking up into pieces is not the same thing as biodegrading into simpler structures that the natural environment can use. There are very few plastics organisms can use as a food source, so it doesn't get turned back into soil the way natural materials would. Even as these pieces get smaller and smaller and smaller, it's still plastic, and it still is not going away. And that brings us to infographic number 1 on page 236. Humans produce a lot of trash, but, unlike other species, the way we discard it and the types we generate make it hard or impossible for nature to reuse or recycle. Our linear system of take, make, use, discard needs to be replaced with a circular system like that of nature. Take, make, use, put back, use again. And that can be used by us or other species. And that brings us to key concept number 2. Household trash contains a variety of items, much of it food or packaging waste. Though this municipal solid waste is a small part of the total waste produced, volumes are still significant and worth efforts aimed at reducing the trash we produce. So almost any human activity you can think of generates some form of waste. Processes that produce food, consumer goods, and our roads and buildings generate agricultural, industrial, and construction waste. The harvesting of coal and valuable mineral resources like gold and copper generates mining waste, which can pollute air, water, and soil. Together, industrial, agricultural, construction, and mining waste make up most of the United States solid waste. Estimates range from about 91 to 97%. The remainder is produced in the increasingly complicated act of living, in houses, apartments, dormitories, and small businesses around the world, and this is referred to as municipal solid waste, or MSW. Currently, urban dwellers produce most of the world's municipal trash, about 2 billion tons of solid waste each year, and this amount keeps increasing. The per capita rate of trash generation is positively correlated with the income level of a country. Curiously, plastic trash is one type of waste that is not as closely tied to income. Its production rates in countries around the world are about the same regardless of income. Americans create more garbage per person than just about any other country in the world. Only Canada has higher per capita values. In 2015 alone, each American produced about 4.5 pounds of solid waste per day, up from about 2.7 pounds per day in the 1990s. With more than 300 million people living in the United States, this adds up to about 260 tons of household trash per year. That's twice the per capita amount produced by some other wealthy countries such as Belgium, Norway, or Japan, and as much as 10 times the amount produced by most less developed countries. The vast majority of this garbage comes from a familiar array of goods: paper, wood, glass, rubber, leather, textiles, and of course plastic. Plastic is cheap enough to have become a staple of both advanced and developing societies, light enough to float, and durable enough to persist for hundreds of years across thousands of miles of ocean. Of course, there are good reasons to use plastic. Plastic helmets are strong but light. Plastic car parts make vehicles energy efficient since they reduce the overall weight and are highly durable. Single-use medical plastics minimize the risk of infection, while plastic prosthetic limbs are lighter and more flexible than wooden ones. But we also find plastic in parts and places that may not be needed. In packaging, straws, bags, and toys. Plastic packaging can help to extend food's shelf life, but amounts used may have more to do with marketing than safety. Plastic now makes up about 13% of our municipal solid waste stream, with packaging making up the largest single category. Very little of our plastic waste, about 10%, is recycled, while 67% is buried in a landfill and 14% is incinerated. Unfortunately, our love affair with plastic only seems to be growing. On average, plastic production doubles about every 11 years. And that brings us to infographic number 2. Municipal solid waste is the trash produced by homes and businesses. Though the volume of industrial and agricultural wastes far exceed the amount of municipal solid waste in the United States, we still produce millions of tons of municipal solid waste annually. This makes actions that reduce municipal solid waste worth the effort. And in this slide, we see a pie graph that details the percentages of the various types of municipal solid waste generation before recycling in the United States. And that brings us to key concept number 3. Uncollected and mismanaged solid waste contributes to a variety of environmental problems, like flooding, air, and water pollution, which can contribute to environmental damage and health problems for humans and other species. So in the cities of the United States and other developed countries, municipal solid waste makes its way from garbage cans in our homes and places of work to garbage trucks, and finally to one of several kinds of waste facilities. Unfortunately, close to half of the world's population, that is about 4 billion people, do not have access to any form of waste management. In other words, their garbage is not picked up and hauled off. There are no municipal dumpsters where they can throw their trash, so they toss it where they can, on the ground or in the nearest river. When no formal waste disposal system is in place or it is ignored, trash often ends up on the street where it can block storm drains, causing flooding, and create puddles that attract disease-carrying mosquitoes, flies, and rodents. Dust from open dumpsters pollutes the air along with smoke from burned trash. Plastic bags clog outboard motors and make fishing a daily struggle, and in many coastal areas, discarded plastics cover beaches, making sand barely visible. In addition, chemical waste tucked into this trash has the potential to wreak havoc on plant and animal life, including, of course, humans. Even our modern disposal methods can contribute to health and environmental problems. Incinerators create air pollution, and landfills produce methane. Furthermore, improperly discarded trash often ends up in bodies of water where record amounts are accumulating. So an example of this is in the ocean. Plastic debris causes all sorts of problems. Many discarded plastics collect in what are called ocean garbage patches. That is, regions of the ocean where strong currents encircle central regions with weaker currents. These are called gyres, making it difficult for waste to drift out once circled. More than 100,000 plastic pieces per square kilometer have been found in the North Atlantic gyre. And surrounding or just below the surface of all the visible plastics are invisible ones. The microplastics that Mason and others know are virtually everywhere. Plastic debris in the ocean can harm marine organisms in various ways. First, plastics can transport organisms to places they don't belong or where they can't survive. Floating plastics can become covered in fish eggs, barnacles, and other young organisms, which then travel to new locales where they can become invasive species. Sea life can also get fatally tangled in discarded shipping nets, shopping bags, and plastic six-pack rings. Organisms eat plastics too. Many seabirds are particularly vulnerable, ingesting large amounts of plastic. Plastic bits they pick up, mistaking them for food, or plastic that is in the prey they capture. To a sea turtle or whale, plastic bags look much like their jellyfish prey. A gut that fills with plastic may no longer be able to hold enough food to keep the animal alive. When an emaciated whale found in the waters of the Philippines was necropsied after its death, researchers found its stomach packed with 88 pounds of plastic bags, nylon ropes, and other debris. It likely died of starvation. Organisms can also be harmed by toxic chemicals the plastics harbor. Many plastics also release hormone-like compounds. A 2011 study found that 70% of the plastics released chemicals that mimic the hormone estrogen. These compounds may interfere with reproduction or the development of exposed organisms. Researchers have also found that marine copepods, tiny crustaceans, exposed to low levels of polystyrene microbeads do not feed, grow, or reproduce normally, among other things. They produce smaller eggs that are less likely to hatch. Plus, if marine organisms are eating plastics, then we are eating it too. For example, shellfish, like mussels and oysters, which is an important food source for humans, can accumulate large amounts of microplastics. A recent study estimated that the average American consumes 50,000 microplastic particles a year via food and drinks. And the same study cited that Americans also inhale another 70,000 particles from the air. Mason's own research has found microplastics in tap water and even higher amounts in bottled water and beer. It's unclear what health effects, if any, these exposures may have on humans, but the varied effects seen in animal studies are cause for alarm. So to be sure, not all of the trash accumulating in the ocean gyres is plastic, but other types of waste like textiles, glass, wood, and rubber sink or degrade relatively quickly. Plastic just floats along. Eventually, time, salt water, and sunlight break it down from its recognizable everyday forms like combs, candy bar wrappers, plastic straws, into fragments so tiny that even thousands of them together can't be seen by a naked eye trained on a calm sea. According to a report by the MacArthur Foundation, the amount of trash entering the ocean will continue to increase, potentially quadrupling by the year 2050. By that point, our oceans may contain more plastics by weight than fish. And that brings us to infographic number 3. The negative impacts of improperly managed solid waste are varied and serious, threatening the lives and well-being of humans and other species worldwide. And that brings us to key concept number 4. While better than open dumps because they bury trash in a way that reduces air and water pollution, sanitary landfills reduce decomposition rates of trash and produce methane, a powerful greenhouse gas. So proper solid waste management is crucial to keeping it out of our lakes, rivers, and oceans, out of forests and grasslands, out of gutters and backyards, and away from disease-carrying insects and rodents. Here in the United States, we have a long history of dealing with waste and a variety of ways to deal with our trash. While all the methods have drawbacks, some are more environmentally damaging than others. All solid waste in the United States is regulated by the 1976 Resource Conservation and Recovery Act. As with many federal environmental laws, the Environmental Protection Agency is tasked with providing the rules and regulations to administer the law. States are in charge of implementing it within their jurisdiction. Through the Resource Conservation and Recovery Act, the United States has long banned the use of open dumps for waste disposal, as have many other developed countries, because dumps are one of the cheapest ways to get rid of human trash. They are common in less developed countries. Indeed, many areas, entire communities spring up around the dumps, and people survive on what they can scavenge from them. However, there are good reasons open dumps are banned in many countries, reasons linked to health and environmental problems. Open dumps attract disease-carrying pests such as flies and rats, a human health hazard. Open dumps also contribute to water pollution. Rain either washes chemical pollutants away from the dump to surrounding areas or pulls it along as it soaks into the ground. If this contaminated water, called leachate, continues to travel downward, it can contaminate the soil and the groundwater. These open dumps are also key contributors of the plastic pollution reaching the sea, beginning as large pieces of plastic, bottles, food packages, clothing, straws, bags, etc., that break down into smaller and smaller fragments and fibers. So sanitary landfills, which are more common in more developed countries, seal in trash at the top and bottom in an attempt to prevent its release into the environment. Several protective layers of gravel, soil, and thick plastic prevent leachate from delivering toxic substances to the groundwater below the landfill. The trash is covered daily with a layer of soil that reduces unpleasant odors, thus attracting fewer pests. But there are downsides to landfills. The compacting of trash under layers of soil excludes oxygen and water so well that the aerobic bacteria, that is, those that require oxygen to live, and other organisms that normally decompose the biodegradable waste can't survive. Newspaper that would degrade in a matter of weeks is preserved in landfills for decades. Anaerobic bacteria, that is, those that live in oxygen-poor environments, pick up some of the slack. But they break down the trash much more slowly and produce a great deal of methane in the process. Methane is a combustible greenhouse gas that contributes to climate change. A way to deal with this methane is to capture it to make electricity, turning trash into an energy source. This process does release carbon dioxide when the methane is burned, but since methane is a much more potent greenhouse gas than carbon dioxide, this is preferable to letting the methane escape unimpeded into the atmosphere. Landfills also take up a large amount of space. This means communities where land is at a premium may have a hard time finding land to site as a landfill. And then there's the NIMBY problem. Not in my backyard. Environmentally undesirable projects like landfills, incinerators, or other objectionable land uses are often met with strong and vocal opposition. Since few people want waste disposal sites in their community, it is often disenfranchised. to poorer communities that find themselves saddled with these installations. The inequitable exposure of low-income populations to actions that degrade their environment is considered an environmental justice issue. Each method of dealing with trash comes with its own trade-offs, and the Environmental Protection Agency has identified a hierarchy of preferred municipal solid waste disposal methods. At the top of that list is source reduction, that is, ways to prevent materials from ever entering the waste stream, followed by recycling and composting, then disposal methods that allow for energy capture. Landfills are the last choice. Sadly, we are not meeting those goals. Landfills handle not the smallest percentage of our trash, but the greatest percentage, slightly more than half of our waste. And that brings us to infographic number 4. In a sanitary landfill, an area is dug out and lined to prevent groundwater contamination from leachate. Trash is dumped and covered with soil frequently. This soil may take up to 20% of the landfill area. Newer landfills have a leachate collection system built in. Older landfills, on the other hand, can be retrofitted to collect leachate. Leachate from holding ponds is treated before being released into the environment. And that brings us to key concept number 5. Incinerators can reduce the volume of trash tremendously and generate electricity in the process, but they produce air pollution. And the ash is hazardous due to the presence of chemicals in the trash. So joining landfilling at the bottom of the EPA's list of disposal methods is incineration, that is, the burning of trash. A lot of garbage, thousands of tons per day, winds up in specially designed incinerators. In the United States, about 12.5% of our trash is incinerated. Europe incinerates a much higher proportion at 42%. Burning waste in this way reduces its volume dramatically by about 80 to 90%. In addition to decreasing the volume of trash that must be disposed of, incinerators offer another benefit, converting garbage into usable energy. The heat produced during incineration can be converted into steam energy or used to produce electricity. For this reason, the EPA considers incineration with energy capture as a better waste disposal option than landfilling or incineration without energy capture. Despite these advantages, incinerator projects are often met with NIMBY protests. Burning waste that contains plastics and other chemicals releases toxic substances into the air, polluting local air and water. Burning also produces toxic ash, which must be disposed of in separate, specially designed landfills. Incinerators are also extraordinarily expensive to build, and tipping fees, that is, fees charged to drop off trash, are usually much higher at an incinerator than at a landfill. Some communities even face the problem of needing to import trash to keep their incinerators running most efficiently. And that brings us to infographic number 5. Trash can be burned at very high temperatures in incinerators, some of which are designed to also generate electricity. Fuel oil must sometimes be added for more complete combustion. In modern facilities, cleaning systems remove particulates, sulfur, and nitrogen pollutants, as well as toxic pollutants such as mercury and dioxins. The ash is considered toxic waste and must be buried in the hazardous waste landfills. Municipal solid waste, medical waste, and some hazardous waste are incinerated in the United States. And that brings us to key concept number 6. Some municipal solid waste is considered hazardous and must be properly managed, recycled, or disposed of to reduce health risks and environmental contamination. So a portion of our solid waste stream presents a health risk of some kind, making it hazardous waste. Most households often contain a bevy of dangerous chemicals and products, so much so that most of us are exposed to more hazardous chemicals indoors than we are outdoors. Household cleaners, paints, automotive supplies, fluorescent light bulbs, and batteries. All of these common household items and many others are hazardous and should not be disposed of with the regular trash. Unfortunately, many U.S. citizens do not know how to properly dispose of hazardous wastes or even which items are hazardous, and simply toss those dead batteries and half-full cans of paint into the trash, where they end up in a landfill or an incinerator and possibly contaminate the environment. Avoiding this contamination requires some investigative research on the part of every citizen. Look into the local plan for your community or university so that you can safely dispose of used batteries and chemicals. The solid waste department for your city or county is a good place to start. A new modern category of hazardous waste, which is e-waste, discarded electronic devices such as computers, cell phones, and televisions, or any device that contains a circuit board. These devices contain significant amounts of precious elements. Reclaiming these materials from e-waste can reduce our need to extract them from mines, a process with a huge environmental impact. Organizers from the Tokyo and Vancouver Olympics used e-waste to make medals for the Olympics. Because these electronic devices contain hazardous materials, they should not be thrown out with the household trash. Currently, 20 U.S. states prohibit the landfilling of e-waste because there is no federal e-waste policy. Much of our country's e-waste still winds up in landfills or is exported in convoluted e-waste streams that most often send it to countries in Asia or Africa. Many of these devices are harvested for usable parts or repaired. The rest is broken down to retrieve useful minerals, or they are discarded or often burned. Unfortunately, despite international scrutiny, this dangerous process is still often done manually by workers using rudimentary tools and no protective equipment. When hazardous chemical components are released by unsafe and poor extraction methods, these substances cause a wide range of medical conditions in workers or community members. From birth defects to brain, lung, and kidney damage to cancer. Since only a small part of e-waste is recycled safely, about 20% was documented to be recycled properly in 2016, consider holding on to your old ones as long as possible before that upgrade to reduce the generation of e-waste. And that brings us to infographic number 6. Hazardous wastes are those that are toxic, flammable, explosive, or corrosive like acids. Many chemicals that enter your home are quite dangerous and should not be discarded in the regular household trash. The EPA recommends that you contact your local solid waste agency for information on disposing hazardous materials. And that brings us to key concept number 7. Composting organic trash is a waste disposal method that mimics nature. It allows waste to decompose quickly and produces mulch-like products that can be used to return nutrients to soil. So there are many ways to reduce the solid waste we send to landfills or incinerators. While non-degradable trash like plastics presents a challenge for disposal, much of what we throw away is biodegradable, and we have a disposal method at hand that emulates nature to deal with this part of our waste stream. Composting can turn organic material into a soil-like mulch that nourishes the soil and can be used for gardening and landscaping. Composting can be done on a small scale in homes, schools, and small offices, or on a large one in municipal digesters. Because they expose biodegradable waste to excellent conditions for decomposition, both small and large-scale composting can break down organic waste, such as paper, kitchen scraps, and yard debris, very quickly. In a home compost pile or bin, kitchen waste might be turned into a soil-like product in just a few weeks or months, depending on the temperature, the amount of moisture, and the number and variety of decomposing organisms at work. Stirring frequently to keep it well aerated, and adding worms to break down material and begin the transformation process to a home composting bin can speed up the process. On an industrial level, a municipal composter can take what was once household trash, that is, smelly, full of food waste, packaging, and other biodegradable things we throw away, and in just a few days turn it into compost. In one such facility located in Tennessee, this accelerated rate of decomposition is accomplished in a huge, cylindrical, rotating digester that keeps the waste moving to prevent compaction and exposes the material to the ideal temperature, air, and moisture conditions. Sewage sludge is often added to provide a bacterial boost. The compost is then removed from the digester and piled up to allow it to continue to decompose in a sheltered place. In just a few weeks, it is fully cured and ready to be used on gardens or in landscaping. Composting is a natural way to deal with biodegradable trash, reducing the volume of trash destined for landfills or incinerators, but ecosystems offer another insight to the problem of solid waste. Just as diversity in an ecosystem enhances its functionality, we stand a better chance of solving our solid waste problems if we pursue a variety of solutions. One of the most meaningful steps we can take is to produce less waste in the first place. Manufacturers can take steps to reduce the waste they produce by recycling product components, increasing the efficiency with which they use resources, and working with other industries. The waste of one industry could be the raw material needed for the production processes of another. But it doesn't stop there. Consumers also have an important role to play. And that brings us to infographic number 7. Composting can reduce the amount of a household's trash tremendously. A simple compost pile can be started in the backyard or a compost bin that can be built or purchased. Municipal composting facilities process household waste after recyclables and non-biodegradable materials have been removed. And that brings us to key concept number 8. Consumers can reduce their generation of waste by using less, reusing or recycling what is used, and closing the loop by purchasing recycled products. So advertising, a virtual staple of advanced societies, bombards us from every corner of modern life, not just on the television screens in our living rooms, but on taxicab computer screens, billboard-laden subway cars, and the pop-up ads that invade our laptops. The message is surprisingly uniform. To live a happy, more fulfilling life, we simply must have more stuff. But this stuff requires resources to produce and package, and waste is generated every step of the way, not just when we discard it. One solution to the problem of waste is using less stuff so there is less waste to begin with. It is for this reason that the EPA identifies source reduction as the number one choice for addressing our solid waste problems. So how do we start making different choices? As any good environmentalist will tell you, it comes down to the 4 R's: refuse, reduce, reuse, recycle. First, we can simply refuse things that we don't need, especially if they are harmful to the environment. When we save a resource by refusing to use it, that resource lasts longer, which in turn means that less pollution will be generated disposing of it and producing replacements, and more will be available for future uses. Refusal doesn't mean never using a resource. It really just means using it at a more sustainable rate. Avoiding disposables, choosing goods with no packaging, or declining a bag at checkout are all examples that help us refuse. You can make a simple commitment to never use plastic bags, water bottles, or straws. If we can't completely refuse a given commodity, we can still try to reduce our consumption of it or minimize our overall ecological footprint by making careful purchases. Choose durable, repairable goods that will last. If you find yourself in a situation where you need to purchase a bottle of water, then buy the largest one you can use rather than several smaller bottles. This reduces the amount of plastic you will be using. And all consumers can greatly reduce the amount of waste they generate by paying special attention to packaging, which accounts for 1/3 of all U.S. trash and roughly half of all paper used. If we can't avoid using a product, our next best choice is to reuse, the third R. Something consumers can do with just a little effort by choosing versatile and durable products over disposable ones. A product that is produced for limited use is really just made to be trash. They pull resources out of the environment and produce pollution at every step of the process, shipping, and disposal. Whether you are purchasing clothing, razors, cups, or plates, ask yourself, how long will this last, and for what other purpose might it be used? Reusing also applies to industry. TerraCycle is a U.S. company that began its life packaging liquid worm compost fertilizer in used soda and water bottles. The company has expanded to offer a number of services aimed at reducing waste, such as an enterprise known as Loop. Though currently available only in certain parts of the country, with expansion on the horizon, Loop offers name-brand food and household products packaged in reusable containers, shipped directly to the customer's door. Consumers use the products, and when finished, the empties are picked back up to be returned to the company, where the containers are cleaned and readied for reuse. This is reminiscent of bottle deposit programs of the past, in which consumers paid a small fee when they bought a drink and were reimbursed when the bottle was returned for cleaning and reuse. Once we have refused, reduced, and/or reused a given commodity as much as possible, we are left with the final R, recycling, the reprocessing of waste into new products. Recycling reduces the trash we generate, but it does more than that. By reclaiming raw materials from an item that we can no longer use, we limit the amount of raw materials that must be harvested, mined, or cut down to make new items. In most cases, this helps conserve limited resources, not only trees and precious metals, but also energy and water. However, notice that recycling is our fourth R. It is our last choice. While better than discarding the item to be landfilled or incinerated, recycling requires more energy, water, and other resources than the first three R's. Recycling of plastic and aluminum containers is being encouraged in some European countries and U.S. states with container deposit programs that repay the deposit when the bottle or can is turned back in, often in a reverse vending machine. Rather than putting money in to receive a drink, you put in a bottle or can and receive money. So unfortunately, recycling programs have taken a hit in recent years thanks to policy changes in China. The United States and most other developed countries used to send the bulk of their recycling to China, whose rapidly growing economy thrived on recyclable material that they collected. This even influenced the way recyclables were collected in the United States, changing in many places from collection sites that asked consumers to sort their recyclables into single-stream recycling bins into which all of our recyclables could be placed. But single-stream recycling leads to high rates of contamination. In this method, many recyclable plastic or paper items become contaminated with food or grease. Non-recyclable items, most often plastics that cannot be recycled, are also thrown in the bin due to uninformed residents adding the wrong items to the bin. Often the results of wish cycling, putting things in the recycling bin hoping that they can be recycled. Due to these high levels of contamination and the growth of local collection of recyclables to feed their industry, China stopped accepting imports of recyclable plastics in 2018, leaving us with a mountain of recyclables and too few U.S. facilities to handle it. This means that some plastics turned in for recycling are ending up in landfills or incinerators, and some communities are cutting back on the recyclables they accept. What to recycle has always been an education problem. In large part, it differs from community to community, and it changes from time to time. Better education on what can be recycled and how to prepare it for recycling is needed. Sorting recyclables at drop-off centers or changing it back into multi-stream recycling, that is, different bins for collection of different items, tends to lead to better net recovery rates because there is less waste that must be removed and less chance recyclables will become contaminated and rendered unusable. But properly turning in recyclables is only part of the answer. To execute this step properly, we must have purchased items that can be recycled. We must also close the loop by purchasing items that are made of recycled materials to encourage manufacturers to make those products. This last step is key. Reconfiguring the plastics industry from a linear production model, take, make, discard, to a circular one that produces items that are recyclable and then recovers and recycles plastics is seen as a key part of any solution that effectively addresses plastic pollution. For the world's solid waste problem to be properly addressed, especially all that plastic ending up in the world's lakes, oceans, atmosphere, and soil, steps must be taken to implement proper waste disposal methods in both developed and developing countries. But if we take a stand as a society and reject the use of unnecessary plastics, we can make a difference. In 2015, as a direct result of Mason's research, Congress passed the Microbead-Free Waters Act, a federal law that prohibits the use of plastic microbeads in certain personal care products, including toothpaste. Even local activism can make a difference. A 2012 single-use plastic ban in San Jose, California, led to an 80% reduction in plastic bag litter in local storm drains, a 60% reduction in local creeks and rivers, and a 59% reduction in city streets and neighborhoods. We are both the problem and solution when it comes to plastic pollution. By refusing disposable plastic, we can be the change we wish to see in the world. And that brings us to infographic 8. There are ways to reduce the amount of waste we generate, but for the waste we do have, there are better options than simply throwing away many products. An item like a plastic bottle can be recovered and reused, or the bottle may be recycled into another product. And that brings us to our core message. Human waste may be unrecognized by us, but profoundly affects the environment. It accumulates unless reused or recycled. It can be toxic to other living organisms, and our actions must change to address these issues. In summary, we all need to be accountable for the waste we produce and the profound effects it has on the environment. To become more sustainable, we must make an effort to generate less trash. Steps must be taken to implement proper waste disposal methods in developing countries and to reconfigure the plastics industry to follow a circular production path. If we do not reduce our dependence on plastic and improve our disposal methods, by 2050 there will be more plastic bits in the ocean than fish.